Hello everyone and welcome to the coding tutorial for this workshop. In this tutorial we would be going over the frozen lake example that we looked over in our previous video. So this tutorial would be a code rundown to better understand what this game is all about, and it will be easy for you to understand the reinforcement learning concept wherein we use the QLearning algorithm. So just for a reminder, if you see this image, this game was about the agent which starts from a starting point and has to reach a goal state without falling in the holes, and finding the best optimal way to reach the goal location. So if the agent falls on the hole, the game gets restarted and gets a reward of 0. And if the agent falls on the goal, the game again gets restarted, but the reward is 1. So let's look into the code. We first import numpy, and then we import the random function from the numpy library. Then we initialize a class called frozen lake simulation. We take a variable called location, state, the actions list, a dictionary of the action combinations such that we could remove them, and also an action dictionary which has the XY coordinates basically. So we would set the current location to 0, 0, the current state to 0. The action list would be down, up, right, left. The actions that we need to remove would be down and up, up, down, left, right, right, left. So supposedly, if the action is down, the up action would be removed. If the action's up, the down would be removed, and so on and so forth. In the action XY dictionary, this is the action movement coordinate based. So if it's down, the current location would be 1, 0. If it's up, it will be -1, 0. Left would be 0, -1, and right would be 0, 1. And then we take a variable called lake, and we give an input of the array of the lake, basically this image in an array format we put into a variable. And then we define a function called state such that we can retrieve what the current state the agent is in. And now we make a retrieval function wherein we perform all the action. So here we set a variable called possible actions, and it's basically a list of all the actions defined here. Action list, it's this list. And then we have possible actions dot remove, which is wherein we are calling the remove action dictionary into this, such that whenever an action is put into this dictionary, that related value is removed. Now we store the information related to the 3 possible actions. So we have up, down, we have down, left, right, because or any set of 3 actions, because 1 is automatically removed since it's an opposite action. So here we have T, R, capital R, small r, and SP. So here T, if we look down here, T would be the transition probability, R would be the reward, and small r would be reset. SP would basically be the state of the agent. So here we're doing numpy.zeros, and we have 3 in the bracket. This is because it's related to the 3 possible actions. Now we want to ensure that only the valid states are retrieved. So if it is state 5, 7, 11, or 12, it needs to be ignored. So if you look at state 5 and we go back to the lake, so we have 0, 1, 2, 3, 4, 5. So 5 is a whole, and 6, 7, 7 is a whole, then 11 is a whole, and 12 is a whole. So these are the positions, these are the states that are not valid because the agent doesn't have to slip into a hole. It has to only be on the frozen areas. So these holes aren't the valid states, and we want to ignore these. So if the states are 5, 7, 11, or 12, we would return the current state of it, the possible action, and then we would just reset the game basically. And now if we want to obtain the location from a state, we just do a mathematical calculation here. We do state divided by 4, and then state divided by 4 the quotient, because double backslashes would give the quotient and the percentage sign would give the remainder. So this way we could get the location from a state. And now we want to retrieve the information for the action. So we would loop over the possible action list, and we would try to set the action in a variable A. Then we would try to find the location at location where the agent is, and then individually put that into y and x coordinates. And now we do this calculation to make sure that the agent stays within the boundaries and doesn't go out of it. Now we want to determine reward, and we want to see if we have reached the end state. So we initialize reset and reward to 0. Now, as I said before, states 5, 7, 11, 12 are holes, and the game would would be reset. So and the reward would be 0. So that's what we have done here. So if it's any of these sets, these states, the game would be reset and the reward as usual would be 0. We won't change it. But if it's state 15, which is the goal state, then in that case the reward would be 1, and as I said previously, the game would reset again. So here, as I mentioned before, T is the transition probability, R is the reward, and small r is reset. Here the transition probability is 0.33 because because there are 3 actions, so the probability of every action would be 1 by 3, which is 0.33. So that's what we have originally set it to, and then we just reset and we just return T, R, S, P possible actions, and R at the end after going through each state. These values would be returned. Then we define another function called move, which takes an action, and accordingly the agent would move. So this is, again, we obtain a possible actions from a current state. So with T, R, S, P and possible actions, we know which state the agent is in, and accordingly the possible actions at that state would be returned. Now here we have a list of possible actions which have a transition probability of 0.33. So we would do a random choice, and the range would be 3 since there are 3 possible actions, and then whatever would be randomly chosen by this function, we would set that into a variable called II, and from now on we would be using this variable so for during this in this entire code. Now we set II to state. SP is basically the state which we would put into the state variable, and then we would calculate the location and then we would return it. So at a particular action, given a particular action, we would try to know what the current state is, and from there on what possible actions could be done, and then we would update the next state and the next location, and this would be returned. Now let's put all these functions into action. First is let's try the retrieval function that we previously defined. So first we will initialize, first we would just set the current state to 0, and then we would print it. So after printing, you see that the current state is 0. Now we want to retrieve the possible actions and end states from state 14 if we try to go up. So here if you see the map, this is state 14, and if you want to try, if you want to go up, so what would be the reward and what would be the state of the agent, that's what we need to see. So, and now we would loop over. So we have 3 actions that would be possible at a particular state. So we want to see which would be the best action which would lead us to the goal state. So at the 14th position, we know that at the right of the 14th position is the goal state. So if with action U, which is up, we go to frozen, which would basically be the reward that you would get would be 0, and the reset would be 0. Since it's not a hole, you don't need to reset it. And now if your action is right, you would reach the 15th state, which is the goal state, and now the reward is 1 because that's where you need to be, and your game would be reset. That's why reset would be 1. And if your action is left, again the reward would be 0 and the reset would be 0, since it's not a hole or the goal state. Now let's try to change this and see what would happen. Suppose we take the state 13. Now state 13 is again frozen, and now we want to see with up, down, left, right, or with whatever actions, what reward and reset values we get. So let's run this code, and now we see if we go up, the reward is 0. Up is basically, up is frozen again. This is the 13th state. If you go up, which is frozen, your reward is 0. And then if you go to the right, you would reach the 14th position, which is again the frozen state, so the reward is 0. And now if we go to the left side, which is the state 12, that was a hole, as we talked about earlier, so the game would get reset. And now we want to print the current state. It is currently 0 because it hasn't moved. This was just to retrieve which state the agent currently is in. Now let's see how we can make use of the move function we defined earlier to move the agent and earn some rewards. So here is the second point, which is movement, where we would make use of the move function. So here we first print its current state, which is set to 0, so that's what it has printed. And now we have 3 move statements here, and as we know, all of the actions are randomized. So in our first state, the action which was which came out to be after using the random function was up, and since we know our current state is 0, which means it's in the starting position and it cannot go up, the action up cannot is not applicable on that position, so the end state would be 0, which means it would stay where it is. It would not achieve any reward, and it wouldn't even reset because it's at the starting position anyways. Then the next random action that we get is down, so the end state would be 4. So from the end state 0, it goes down to 4. So now it's at the 4th state, and now that's why it prints the current state as 4. And then the third random action that it gets is up, which is if it gets up again, so now it is at current state 4. After getting action up, it again goes back to 0. That's why the end state is 0, the reward is 0, and it's not reset, and yeah, so and it prints current state as 0. So this is how we first saw the retrieval function being used. Now we saw the move function being used, and now we want to use both of these functions and try to attain the best optimal path for the agent to reach the goal state. And to do so, we would now use the QLearning algorithm. So let's understand this value iteration algorithm of QLearning. So first we initialize a Q matrix, which is an array of 16 into 4, and we have since there are 16 states, that's why we have a 16 into 4 Q matrix that we have initialized here. Then we have our action and state variables, which have actions down, up, right, left, and the states would be 0 until 14, but we would exclude the 15th state. And as you remember, the QLearning formula had a discount rate as one of its in its formula. So here we would set the discount rate as 0.95, and the iterations we would keep as 2000. And now we want to iterate over all the states. So first we would iterate. Have 2000 iterations. We start off with setting. We start off with the 2000 iterations. We make a variable called QPrev, which makes a copy of the matrix, since we don't want to mutate the original matrix. That's why we create a copy of it and store it in QPrev. And now we iterate over states, and then we iterate over the 4 actions that we have, and we retrieve the possible actions using the retrieval function and put all these values into T, R, SP, small r, and n possible actions, if you remember the variables. And then we have a QTemp that we make, which is NP03, because it has 3 possible actions that it could make, since one gets cancelled out, as I had previously talked about. And then we sum over all possible actions, and we apply the we here write the QLearning formula in a code format, so that the QLearning algorithm can be applied, and this can finally be stored into Q, which is the Q matrix. And now we want to visualize what the Q matrix would look like. So here's a print Q, which would print out what the Q matrix looks like after the value iteration algorithm we saw previously. So here is a 16 into 4 matrix, and here basically each value that you see here is the probability of each state probability of each state from which you can reach the goal state. So wherever you see 0, that is those are the holes, and rest are the frozen areas. And now using the Q matrix that we have that's been printed here, we want to obtain a value function. So as I had talked about value function in our slides, so basically value function is just it's a similar thing as Q matrix. It's the probability from each state to reach the goal state, but this is in the shape, we have reshaped it 4 into 4, and here we would get to know the maximum value, the most optimal value from each state to reach the goal state. So here we see 0.147 as S, and so on and so forth, and this is, each value refers to the map that we see here. And now we want to obtain the policy, which is the most optimal action for each state, and here this is the optimal position, action that we get for each state. So here it's 3 1 3 1. So as you remember from the list that we had, 3 was the left action. So left action from the starting point S is not possible, hence it will go down. It cannot do right, because suppose it slips down, it will fall into the hole. That's why it takes so the best action that could be possible from the starting point would be down, would be left. So it's 3 here, and so on. It has calculated the best the most optimal action for each state. So In all these parts, we have tried to understand how the retrieval, move, the algorithm, how to visualize QMatrix and obtain value function. So now we want to combine all of these things that we have learned into a proper code set to understand how this game is played um, in total. So it's just a combination of everything that we have learned. So we again um, define the frozen lake simulator. We initialize the Q matrix. We have the actions. We have states. We have reset to 0. We have a learning rate. We take n iterations as this value and n iterations 2 as this value. We have a discount rate. And now we want to implement the Q learning algorithm. So it's the same value iteration algorithm that we saw previously, and we iterate over the random states, and I mean for every we randomly select the starting state and put it into a value s, and accordingly the agent will decide uh, which value which state is the best to reach the goal state. That is the whole idea of reinforcement learning with the Q learning algorithm. We iterate over each possible state, and then accordingly we uh, give a value to reset, and because suppose if it reaches the goal state, it would be 1. If it reaches whole, then it would be 1. So we give value to rewards and reset according to the state it is in. So here, if the reset is 1, which means we reach the goal set, or we reach the whole, we would reset the whole game and start off with reset equals to 0, and we break out of it. We break out of this, and it goes back into the for loop. But supposedly reset is not 1, which means it is 0, means we can continue on different states with different actions. So after this state, we can randomly choose an action now, and based on that, it can make a movement and go towards the goal state. And here it is again, we apply the learning rate. We calculate this in term 1, and then we make a term 2 where we use this where we apply the Q learning formula, and then we add up the term 1 and term 2, and then we store it in the Q matrix, and S is equal to SP, which means now from the state it is in, it would move on to the next state, and then the whole iteration would continue from there on. So now with the matrix that we get and we printed, this is the matrix 16 into 14 matrix that we have received here, and now we want to obtain the value function. So it's a 4 into 4 matrix which gives the probability at each state, and now we want to find the best policy such that it can reach the goal state. So here we have 3 1 3 1 3 0 3 0 and so on at each state. So by this you can see that the agent has found the most optimal action for each state such that it can get to the goal state by getting rewards and finding the best way to not reset the game by falling into the holes. So yeah, this is the idea of reinforcement learning, that the agent learns from its experience by getting rewards or punishment. So yeah, this is the end of the coding tutorial, and I hope you understood the idea of reinforcement learning using Q learning algorithm. So yeah, definitely make sure to finish the quiz. The link is given below in the description to test your knowledge and for us to know how well you have understood the concept. And yeah, hope you have a great day and can't wait to see your submissions. Thank you.